Okay, let's look at example 1. Okay, I'm going to take a little bit slower so that you can digest the question. Okay, what are the gold nuggets? How do I actually defragment the whole question? Now, a particle P move in a straight line so that the distance s meter from a fixed point O. So I do have a fixed point O is given by a formula s is equals to 12t minus 3t square for t between 0 to 4. Okay, after 4, I don't know what is it already. Okay, so I'm not going to talk about anything after 4. Okay, now find the speed of P after 1 second. So how do I get the speed of P? Now, from only one formula, which is the displacement, okay, given as 12t minus 3t square, okay, what we can do is to get our velocity. My V will be ds over dt, right? Okay, change in displacement, rate of change of displacement. So you get 12 when you differentiate, okay, minus 60. Okay, now P after 1 second is as good as saying, okay, P at 1 second. So at t equals to 1, okay, what is your V? Your V is equals to 12 minus 6, 1. So answer is 6. Answer the question, speed of P. So therefore, a statement, speed of P is 6. Remember the units. Okay, this is meter per second. Now, where do I draw the meter per second? Meter, okay, for the time in second. So meter per second. So this is how you get the speed of P. Okay, now the second part, the distance of P from O when the particle is instantaneously at rest. So one thing, instantaneously at rest is when you must know it infers to your velocity equals to 0. Okay, the other thing you need to know is distance of P from O is actually telling you, do you know what is my displacement? Okay, so what is the very first thing you need to find? Now, displacement is in terms of t, time. So you need to find the time where v equals to 0, right? So at v equals to 0, okay, you can solve my 12 minus 60 is equals to 0. Now, that will lead you getting t is equals to 2. So at t equals to 2, it has rested or is instantaneously at rest. And what is the distance from P? You sub into S. S will be 12 to minus 3 to square. Okay, so when you solve this, you get actually 12. So therefore, again, answer the question, distance of P from O is 12 units meter. Okay, all these must write. Okay, 12 meter. Okay, now comes the interesting part. The total distance traveled during the first 3 seconds. So you know what happened at t equals to 2. Okay, now we do not know where's the displacement at t equals to 3. So this is what I'm going to do. And this is what I want you to practice. Okay, every time you see the word distance, okay, you begin to draw a sketch. Okay, what does the sketch consist of? Okay, the initial part, when t equals to 0 second, okay, s is equals to 0 meter. Okay, so there exists this particle. Okay, now it's going to move to, okay, when time equals to 2, you know that the displacement of P from O is 12 meters. So it's going to go towards your right hand side. So let's say this is t equals to 2 seconds. Okay, your s equals to 12 meter. So the particle is going to move this way. And after that, what happened? It comes to a rest. Okay, now it cannot just stop there because there is motion at t equals to 3. Because what happened is when you sub t equals to 3, at t equals to 3, first 3 seconds, at t equals to 3, what is that displacement? If you stop for infinity, your s will be equals to 12 meter. But when you sub t equals to 3 inside, you realize that, okay, this is what you are going to get. Minus 3 square. We are going to get 9. Meaning to say, okay, ultimately, okay, based on the diagram that you have, right, there is this t equals to 3 second, okay, the displacement equals to 9 meter. So what happened to the particle is that it's going to turn and then it's going to stop here. Okay, this is the stopping point. Okay, so now let's calculate out what is the distance and exactly how do I find the distance. Okay, now the distance will be from, or distance traveled should be this whole stretch add to this stretch over here. Okay, so if you are fast enough, you will realize that, okay, the total distance traveled is going to be, okay, 12 meters all the way to the point where we turn, and then just a little bit more, which is plus the stage 1, 12 meter. Now stage 2, when it turns back, is actually distance traveled is actually 12 minus 9. Because why? 9 is exactly the displacement. 9 meter, and then from here to here is 12, right? So meaning this part is actually 9 minus 12, 3. Okay, so therefore the total distance traveled, if you add them out, it is just 15 meter. Okay, that's how you look at the distance problem.